So we will move to the first keynote speaker, which is Pasquale Steduto. Pasquale, please come here. And Pasquale Steduto is Deputy Director of the FAO Regional Office in Cairo, and also he has many other commitments. And we are dear friends after a long time, and a long time ago Pasquale was working in this institute. We had the office one in front of here. So it is really a pleasure to have here Pasquale as a keynote speaker and as a friend. Pasquale, please, you have the floor.
Thank you very much. Let me thank you also myself, the organizer for this, all the friends and colleagues of the Institute, Pari and Mari, for this kind of invitation. It's always a pleasure to come back to the region, to the roots, and to the place where most of my personal and professional life has been forged, has been initiated. Now, coming to the topic of today, I wanted to draw the attention on one problem that we generally encounter every time we try to address the sustainability of water resource management, and in particular, irrigation management. Generally, all over the world, where there is water scarcity has been mentioned, in the Mediterranean, Near East, North Africa, but all the way through China, some state of the United States, in Australia, where the problem of water scarcity is extremely relevant and will be more and more relevant, generally invoke the efficiency, the productivity of water use, and therefore also the saving that we expect from these processes. And hundreds of millions generally of dollars are invested in modern technologies, in modernizing the irrigation in general, with the expectation that at the end we are better equipped to cope with water scarcity. Unfortunately, more and more evidence are accumulating showing that there are unintended results that most of the time show that this trend, or this approach, makes the water scarcity sometimes worse. And with this presentation, I'll try to illustrate what is the problem, trying to highlight where the confusion comes from, and possibly give some indication of solution, or at least how to address correctly the problem. So let's go straight to the point by first defining briefly what are these terms. So in general, for water efficiency, we can refer to the ratio between a water used by a user for a given purpose to the water applied to that same users. Let's be a little bit more specific when we talk about irrigation. There are several definitions, of course, but let's take one that is quite relevant. That is the water used by a crop via evapotranspiration as opposed to the water applied to the field where the crop is. So this is one way of defining the irrigation efficiency. And here we can observe that because water is on both numerator and denominator is generally adimensional and falls within the theoretical limits of 0 to 1. When we talk about water productivity, in general terms we refer to the benefits that we gain from the use of that water. And in broad sense, it can go to crop, forestry, fishery, but even mixed agricultural system. So it's a ratio between the benefit produced and the water that has been used, as I emphasize evapotranspiration, then you will know why, not the water applied. So the benefits can be considered in a large sense: biomass, kilocalories, if you want to look at the food, protein, income, jobs. So every benefit that you can have from the use of that water. And you can observe in this case we have a dimension. We have kilogram per cubic meter, or dollars per cubic meter, or job per cubic meter. So there is a unit, and there is not anymore the theoretical limit 0, 1 that confines this definition. So in a way, we also know that if a system is very efficient, sometimes it's also very productive, and vice versa. A system is very performant, very productive is supposed to be also very efficient. So there is some area of overlap. But sometimes efficiency can go also in terms of time involved. This faster process can be more efficient than being slow, remaining the rest the same. So what are we having here now is a sort of, let's say, an efficiency that looks more to the process per se, and productivity looks more to the output coming out from that process. But let's go to the third term, water saving. What exactly we refer to? Well, here is where the problem start to come in. So we need first a sort of water accounting framework to make sure that we know what we are talking about. When we use the term water use, generally is not sufficient, because not all water you use is consumed. Generally in agriculture, in irrigation particularly, we have to distinguish between consumptive use and non-consumptive use. And generally, for the consumptive, you have the one that is beneficial, generally the transpiration of the crop that generate the yield from that crop, or the one that is not beneficial, like evaporation from the soils or the transpiration of the weeds. On the other side, there is water that is not consumptive, used. And in this case, you can recover some of that water, like you generally have in the drainage. You have a so-called return flow. And so there is a quota that is recoverable by the system, and a quota that is not recoverable. So the one that is not recoverable is something that is lost eventually, and where efficiency can, let's say, serve to not to lose that water. But the point is that when we talk about evapotranspiration, it's exactly the water that is consumed by the crop. So we know that now that the water saving actually we refer to that water that would be no longer available to the system under consideration. And here there is an issue of scale. But with that framework, you can distinguish now that I save water if I reduce my consumptive use. And actually, because my crop will continue to grow and needs to transpire, where I can save is if I reduce my non-beneficial consumption. Similarly, if I have a part of my irrigation applied that is not recoverable, and this is the case when you have over-irrigation and maybe it goes in the groundwater, and that groundwater is not accessible anymore, then it's not recoverable. If I increase the efficiency, of course, I save something. So this is the framework for which we needed to consider before defining if really every efficiency or productivity that we put in place to improve the performance of our agricultural irrigation system is going in the right direction according to the sustainability demand. Now, let's proceed by example and look at the cases where you have less efficient or more efficient situation, more productive, less productive, and see if we are saving more. So, first example, let's make the case in which you have from whatever source a diversion of, let's say, 10,000 cubic meters goes to the field, 1 hectare field, and I have an efficiency of 50%. According to the first definition, half of that 10,000 is lost by evapotranspiration. Maybe the other half goes away either through runoff or through deep percolation, and I have 100 tons of production. It's just an example. Now, I make a case in which I improve the efficiency, and for the sake of simplicity, I go with 100% efficiency. What generally happens in several cases is that the farmer say, oh, I have 5,000 that goes in the first field. The other 5,000 that before was going either runoff or percolation, I can expand my surface of another hectare. So at the end, with 100 efficiency, what I have, the total water used, as you can see, is the same. 10,000 used before, 10,000 used now, but the one consumed in the first case was only half, 5,000. In the second case, is twice, so it's double. But also my production is double, no? Because the farmer now can irrigate 2 hectares. So the benefits is more production and possibly less pollution because there is less water through runoff or through deep declaration. But did I save water? No, actually I consumed even more because evapotranspiration is the consumptive use. It's the one that goes and I don't have any more available to my system, so it's considered a real consumption. Example number 2. I have a less water productive crop. Okay, so I have the case of 5,000. I have 100% efficiency. My water productivity is 20 kilogram per cubic meter, and I get 100 tons per hectare. So, because I'm 100% efficiency, all my water use is consumed by evapotranspiration. Now, if I use a new crop, a new variety, which is more water productive, and let's assume it has 24 now kilogram per cubic meter, still it will consume the same amount, but it will produce more. 100 is more productive, 120 tons against 100 tons per hectare. So what I have, that the total water used in this specific example is the same. The total water consumed is the same, but the yield is higher. So the benefit is higher yield. Did I save some water? No, I still consume the same of the less water productive. Okay, let's go to the third example, diversion from a river. Assume that you have 100 units, along the river. At some point you divert 80 with your efficiency at 70%, the crop evapotranspires, so consume 56 units, 80 minus 56, 24, let's say, is a return flow. So 100 minus 80, you have 20, then plus 24, you get 44. In the case of a more efficient water use, I go from 70 to 90. So I say, okay, I don't need all 80, I need 62 at the most. The crop consumes the same, the return flow is minimal. I need still some. And at the end, what is the difference is that here I divert more water and comes back maybe even diluted. Here I divert less. So if I analyze the comparison, the total water used in this case is reduced. But the return flow, the recoverable part of that water, is reduced as well from 24 to 60. The yield is the same. The total water consumed is the same. But the benefits are less pollution because less return flow. More water in the stream, as you can see, because I divert less from the river, I have a higher, let's say, water flow into the river. And eventually I have less infrastructure to withdraw. Instead of 80, I withdraw 60. So in a way, I have less investment. So if I look at these benefits, there are, of course, benefits. But did I save some water? No, you still 56 and 56. The crop that produced a certain amount, it will consume the same amount. So the actual situation of sale is still questionable. Then the last example, the draw from groundwater. Generally, you can have, like in the first case, a less efficient water use, where 10,000 cubic meter, this is assumed over a year, let's say, of the whole crop cycle. I have an efficiency of 50%, half of that 10,000 or 5,000 is consumed, I produce 100 tons, and I have 5,000 cubic meter goes back maybe into the groundwater. If I'm more efficient, and I do again the case of 100% efficient, I can pump less. I can pump only what I need, 5,000. This is consumed, so this is a very, let's say, peculiar case. 100% is never the case, but for the sake of simplicity, So you don't have any water back into the groundwater. So in this case, the total water used is reduced from 10 to 5,000. The total water consumed is the same, 5,000 in both cases. The yield is the same. So the benefit actually is that I need less energy to pump and less pollution because less water goes back into the groundwater. So I have a series of benefits. But again, did I save some water? No. So let's take some key messages from those examples. Strictly speaking, water saving does not come from higher irrigation efficiency or higher water productivity, but from reducing the consumptive use and the non-recoverable fraction of the non-consumptive use of water. So you need that framework to distinguish the fraction, where the water goes, to see if you are saving or not. Improved irrigation efficiency and water productivity are beneficial to farmers. So we are not saying that this is not good. This is good. There are several benefits to farmers, but not necessarily to water resource manager concerned with water saving. Okay? And then we observe that if you really want to achieve water saving, you have to set first the limit of water allocated to a use, in this case to a crop, to a farm, and then use any measure to increase efficiency and productivity of water, considering, of course, the adoption of the solid water accounting framework. This is basically, it's like saying that if I don't set the limit of consumption and I just go with efficiency, the case are accumulating that the water is getting consumed anyway. So you are not really saving. It's like saying a car that is less efficient, you can do 10 kilometers with 1 liter of gasoline, and now you have a new car which is much more efficient. You do 20 kilometers with 1 liter of gasoline. But if I travel the double of what I was traveling before in 1 year, I'm still consumed everything like before. So this is the idea that we need, for a sustainable water resource management, especially in irrigation, we need to set the allocation quota. So the confusion comes, in fact, in the use of the term. In 2013, the Netafim, I think most of you know, Netafim is a big company from Israel making drip irrigation. It's a pioneer leading this drip irrigation. So the CIO of Mr. Gal Eisenberg, in receiving the news that the industry won a water award from the Stockholm Water Institute, International Water Institute, he said, "We are truly honored to receive the Stockholm Industry Water Award as the global pioneer and leader in drip irrigation. We have always focused on saving water." No, they were increasing the efficiency of applied water through irrigation. The real water saving is not clear. You need to enter into the details, so I don't want to read all, but they talk about water sustainability, reduce water usage, maybe yes, but water saving through efficiency. More crop per drop, this is the World Bank, was doing a meeting, a conference, workshop, basically, in Washington, and said, more crop per drop, meeting the challenge of tripling food yields and cutting water use by 70% in agriculture. This is Jain is a irrigation system, is the equivalent of Netafim in India. Okay? So you expect to triple the food yield and cutting the water use by 70%. There is a big confusion there. If the crop to produce a certain yield has to continue to produce 3 times, it has to transpire more. So you will not cut the water. They say you will not save 70%, but you will increase the efficiency of the water use, but not the consumption. And so on. This was the day after. They talked about the water efficiency like energy efficiency, which is a completely different concept. Like we said before, the water used may not necessarily be consumed. Imagine the water that is needed to cool down a
an electric, let's say, or a nuclear power generator. Okay, you need water. He changed the physical characteristics. The temperature passing through is warmer, but it's not necessarily all consumed at all. Actually, little percentage is consumed by that increase in evaporation due to the temperature. The rest is passing by and continuing. So not necessarily all the water used is consumed, but for the energy, if it arrives to your users, is consumed. You don't have anything recovered. It's gone.
We have to respond, in fact, to this idea that water efficiency will eradicate hunger and poverty. There is a lot of going on, but imagine even in California, with the last 4 years drought, there is an institute, the Pacific Institute, with this Peter Blake, his boss, and they made some assessment, and he wrote a message where he says a 4 major assessment of solution for California water problem, including the correct drought, have been just released by the Pacific Institute. In short, we conclude California could be saving up to 14 million acres of untapped water, providing more than the amount of water used in all California city in 1 year, with an aggressive statewide effort to use water-saving practice, reuse of water and capture losses from water. Essentially, we analyzed those studies and we came out that consumptive and non-consumptive use were added together. And then when we separate, actually only 10 to 30% of these 14 million acre feet are actually safe. So it keeps going. We have in Morocco a Programme National d'Économie d'eau en Irrigation that has the expectation to reduce la consommation d'eau from 30 to 50%. That is efficiency. When you read the document, it's an efficiency. It's not a real saving. And this is just in July when the World Bank gave 150 million to Morocco to address more efficient water use in agriculture. Now I use the right term, more water efficient, with a lot of benefit. We are not saying that efficiency or productivity is gone. It's just, are we saving water? We need to pay attention to this. The last one is what I'm following in Egypt. For instance, there is a national program on-farm irrigation development, and the main goal of this program is to improve on-farm irrigation system in all the land in order to save significant amount of water to be used in reclaiming the target areas. So essentially, it's like the first example. They increase the efficiency, and the water that I recover by the efficiency, I go to irrigate additional land. So in reality, you are not saving, you are consuming more. And it keeps going like this. I don't want to spend any more time, but I want only to highlight that there are hundreds of millions of dollars generally invested for this, let's say, modernization, putting drip irrigation, increasing the efficiency, assuming with an underlying assumption that you are going to save water. You get a lot of benefits with the drip irrigation, a lot. But you don't save the water. And this water scarcity, like I think this one, may keep expanding more and more. Now, very briefly, some solution. In open field, because we need to distinguish open and closed field, if we want to increase water productivity and efficiency, of course, you have some opportunity through the crops variety, the drip irrigation, but not forget that if the management is bad, the potential that the drip irrigation provides you is very limited. So generally, the non-beneficial consumption that you can reduce is of the order at most of 10%. This is an overall average to give you an order on agriculture. What you can do more is decreasing the non-consumptive use, evaporation through bare soil or through the transpiration of weeds, so weeding, mulching. An experiment in China, they covered with plastic mulching over 1 million hectares of corn, and they were able to demonstrate also on a larger scale how much you can reduce that non-beneficial consumption of water, or even subsurface, so you don't wet at all the surface of the soil. And generally, the order of magnitude in this non-beneficial consumption is of the order of 20 to 30%. In closed system, of course, you can have much better opportunity. An hydroponic, for instance, when you recycle all the water, there is generally less radiation, less turbulence, less VPD, which means higher humidity in that environment. You already have a sort of reduction of 20 to 30%, and basically non-consumption. But you have even the new generation of greenhouse. Now they are in Spain, in Algeria. We are doing this also in the United Arab Emirates. The stuff to come out is still, let's say, with high tech and high investment. But essentially, all the water that you consume by transpiration inside, beneficial, is recondensed, recycled, and reused also into the system. So, but is high demanding, like I said, in technology and knowledge. This new generation of sterling we are doing also in the Emirates, generally so far you can go up to 90% reduction of water consumption. Okay, so let's close with some remarks by restating that water saving does not relate to the efficiency of crop water productivity, but to water consumption and eventually the non-recoverable fraction of water. Water accounting is fundamental in order to find out if you are saving or not. Of course, the more we can manage the environment where crops go, the more we can control this water consumption, like in the case of hydroponic greenhouse, but not everything can be grown in greenhouse. And then the economic benefit, do not forget that the economic benefit of high-tech irrigation tend to make water more valuable to farmers. So they continue to demand more water. They generally, once the water arrives in agriculture, it never leaves agriculture. Also this idea that then you save and you allocate somewhere else. If you don't act on the allocation and you leave it to the efficiency of the farmers, it will never work. So, to obtain water saving toward sustainable water resource management, sequencing of measuring scheme. First, you have to control the consumption, the allocation, so that is predetermined, and that must precede the on-farm intervention. The mix-up between efficient productivity and saving of water is impeding progress toward water sustainability and proper strategic planning of water resource management. And with that, I'll conclude. Thank you very much for hearing.
Thank you very much, Pasquale, for your very interesting presentation. As you explained, it seems very easy, it seems obvious what you say. Unfortunately, it is not the case. I'm used to go in several conferences and congresses and workshops, and there is really confusion about what does it mean, water use efficiency, or water productivity, or water saving. And the next speaker here, the next keynote speaker is Enrique Playan, which is from Spain. And in Spain, there is a very interesting case of modernization of irrigation systems where water use efficiency increased quite a lot, but water saving is not increasing at all. And also energy problems came in Spain. So I don't add anything because we have a keynote speaker about that. But what Pasquale said is very, very important to have clear in mind when we speak about water use efficiency, water saving are completely different issues.
We are collecting all this evidence from projects, from World Bank, IFA, all the major investors in the country.
And there is no water saving.
We did publish at some point.
Thank you. I will open the floor for a couple of questions, then we move to the coffee break, and you can continue to ask questions to Pasquale Steduto during the coffee break. Just to try to leave the floor to the next chairman with a little delay on the schedule. So, if you have questions, a couple of questions to Dr. Steduto, please, the floor is yours. Please, Talata Wish from Lebanon.
It's very, very important, of course, to achieve higher efficiency of water use. But I am afraid if we practice zero leaching, we accumulate salt in the soil, and when we produce less drainage water, we will send back to the river higher salinity water. So how we can reconcile this with the concept?
Yeah, no. I absolutely agree. That's why the return of flow, of course, I fully agree, has to be part also of the salt balance, not only of the water balance. But I was trying just to put in evidence that even if you want to be as efficient as you want, at the end you don't save water, just for the sake of that. But of course you have additional problems that we have not talked about for the sake of confining and focusing the presentation to the modern technology. Definitely, drip irrigation is the same. There's a lot of problems with the salinity in certain environments. So I fully agree and concur that you need to have even a certain degree of inefficiency and return flow in order to account for the salinity. No question about it.
This is an extremely important point. You've got an important point. I am thinking to the case of Egypt, for example, where there is a drainage water, use of drainage water. If we look at the efficiency at farm level, it's very good. But if we look at the efficiency at the basin level, let's say, it is much higher because of the use of the drainage water. But what about the quality? The quality is something else that probably should be taken into consideration when we speak about water use efficiency. In general. Another question?